Okay, so we have to find the derivative of square root x square minus 1 multiplied by x plus 1 divided by x cube plus 1 power 3 by 2. Now this is actually a bit complicated question because it requires a lot of simplification before applying the derivative. Okay, so let's just continue with the simplification of this question. First of all, let me just write it right over here. So x square minus 1. Of course, we can see that we have a square root right over here, and we know that the square root can be represented by 1 by 2. So we can actually write 1 by 2. Now I've left a space over here. For what reason? Let me just tell you. So we have x square minus 1, right? And if we see this formula, a square minus b square can be used over here. So this thing right over here would be my a square, and this thing right over here would be my b square. Actually, 1 square is actually equal to 1, okay? So we can rewrite this thing in the form of a minus b plus b. So our a is x and b is 1. So we can write x minus 1 and then x plus 1. So let's just put this thing right over there. So we can write x plus 1, x minus 1 power 1 by 2 multiplied by x plus 1 and then divided by, and here too we can open a formula. If we see, we have x cube plus 1, right? The formula a cube plus b cube can be opened over here. So this thing right over here would be my a cube and this thing right over here would be my b cube. So we can use this formula. A is x and b is 1. So x plus 1 a square x square minus ab, which means x multiply 1 plus b square, that is 1 squared. So we can write x plus 1 x square minus x plus 1, and we can put this thing right over there in the actual question. So we can write x plus 1, okay, x square minus x plus 1, and over here we have a power 3 by 2. How can we proceed? Okay, so if I focus on this question for a while, we can see all of these terms are being multiplied. Okay, so there's no operation like subtraction or addition. Okay, so it's very good. I can separate this square on both of these terms present right over here. So I can write x plus 1 1 by 2 multiplied by x minus 1 1 by 2 multiplied by x plus 1. And over here I can also separate this power on both of these terms. So we can write x plus 1 or 3 by 2 and x squared minus x plus 1 power 3 by 2. Okay, so we can see over here when the bases are same, the powers will be added. Okay, so the bases x plus 1 are same, so the powers will be added. So the powers are 1 divided by 2 and 1. So we can add with the bases are same, the powers are added. X plus 1 x plus 2 minus 1 1 by 2. Over here we have x plus 1 3 by 2 x squared minus x plus 1 3 by 2. So when we add 1 divided by 2 with 1, it would be 3 by 2 x minus 1 1 divided by 2 x plus 1 3 by 2 x squared minus x plus 1 3 by 2. Okay, so these terms are cancelled and we are left with minus 1 1 divided by 2 and x squared minus x plus 1 3 by 2. So this is the final form of this question. And now I told you in the previous video that when we are having powers, we are going to use natural log. Okay, so we are going to apply natural log on both sides of the equation. It would be much more simpler to solve it when we apply the logs on both sides of the equation. So we have y over here, so we can apply the logs. So natural log of y would be equal to natural log of x minus 1 power 1 by 2 x squared minus 1 x plus 1 3 by 2. We know that whenever we have log x divided by log y, we can simply write log x minus log y. So the division actually represents subtraction in the log world, you can say. So I can actually subtract these functions. I will be left with minus log of x squared minus x plus 1 3 by 2. Okay, so I hope you get the point. Now finally we are going to apply the differentials on both sides of the equation. So we have log y right over here and log y. So let me just apply the differential right over here, d by dx and d by dx. And let me just tell you a few different formulas which I've also told in my previous videos, but just for the sake of this video, let me just revise those formulas. So okay, so first of all, we have derivative of natural log of y, right? The derivative of natural log of x is 1 divided by x multiplied by the derivative of the same function present right over here. Okay, so we can use this formula right over there. So I can write 1 divided by y. Okay, so y is my function and the derivative of the function. Now we can simply separate the differentials on both sides of this thing because it is being subtracted. So natural log of x minus 1 power 1 by 2 minus derivative of log of, and then another formula. Okay, so we have log something with a power, so we can use log x power m. Okay, so when we have log x power m, we can actually write m log x. Okay, so the power, the exponent will be separated in the case of log. So over here we can write d by dx 1 divided by 2 natural log of x minus 1 minus d by dx natural 3 by 2 natural log of x square minus 1. And I would like to recommend you one thing, that before applying the differentials you can separate these powers. Okay, so I was just in a hurry and I applied the differential on both sides of the equation, and I forgot to separate these powers. So now I am doing an additional step and separating these powers while I am having the derivative. Okay, so it's actually not quite right. So you can just separate the powers first of all, and then you can apply the differentials. Okay, because the log rule is already existing for wherever you are applying a log. Okay, so the derivative is actually not necessary for applying the log x power m formula. Okay, so over here I should have written 1 divided by 2 natural log of x minus 1, and then I should have applied the differentials on both sides of the equation. Okay, so anyways, we can go ahead and we can separate the constant. So we have 1 divided by 2 derivative of log of x minus 1, because the constants will be separated, the derivative won't have any effect on it. Also over here 3 by 2 will be separated, and we have d by dx x square minus 1. And you see, now it's actually quite simple to solve. You have derivative of log of x, which is actually equal to 1 divided by x. Okay, 1 divided by the function of log. The function of log is x minus 1, so we have 1 divided by x minus 1 multiplied by the derivative of the function of log. Now what is the function of log? It is x minus 1. So d by dx x minus 1. Okay, let me just separate this thing by a bracket, minus 3 by 2. Also over here we can simply separate the differentials, x square minus d by dx x plus d by dx 1. We have 1 divided by 2, 1 divided by x minus 1, so the derivative of x is actually 1, and the derivative of 1 is 0 because it is a constant, minus 3 by 2. Over here the derivative of x square would be 2x, so the power will be separated, then the function x, then the power minus 1, 2 minus 1 is actually 1. We have done these things before. Minus the derivative of x is actually 1, and the derivative of any constant is 0, so we have 1 divided by 2, 1 divided by x minus 1, minus 3 by 2, 2x minus. Multiply these things right back into the bracket, so we have 1 divided by 2 x minus 1 in the denominator, minus 3 divided by 2 2x minus 1 in the numerator. Okay, so we can combine these things by using the LCM property. So if I take an LCM, we have 2's are common, so we can write it once, and then x minus 1 is present in only one of these terms, so we have to write it one time. So the 2x minus 1 is actually matching, 1 will be as it is, minus 2 is matching, but x minus 1 is not matching, so we have to multiply it with the numerator. Then we have 1 minus 3, let's just multiply these things. We have 3, 2x square minus 2x minus x plus 1. Okay, so 2x multiply x is 2x square, 2x multiply negative 1 is negative 2x, negative 1 multiplied by x, negative 1 multiplied by negative 1 gives us positive 1, divided by 2 x minus 1. 1 minus, okay, so 3 multiplied 2 is 6x square, minus plus 3 multiplied 2 6x, minus plus 3 multiply 1 is 3x, minus plus minus 3 multiply 1 is 3, divided by 2 x minus 1. Okay, so 1 minus 3 is actually negative 2. Okay, over here 6x and 3x can also be added, so we are left with positive 9. So over here we have 1 divided by y dy by dx, right? We can move this y towards the opposite side of the equation because we want to find the derivative. We want to find the differential of the function given to us. And what is the differential? It is dy by dx. Okay, so dy by dx will be separated. We can simply multiply this y on both sides of the equation. We are left with y multiplied by minus 2 minus 6x squared, that's 9x, divided by 2x minus 1. Now what was the value of y? Let's just put back the value of y. X square minus 1, x plus 1, x cube plus 1, 3 by 2. Now this was the actual value of y. You can put this value too, or you can also put another value. So we can write x minus 1 divided by 2, x square minus x plus 1, 3 by 2, and then the same thing right over here, minus 2 minus 6x squared. So this is the final derivative of this exponent given to us.